So now we come to the next part on, so far I have discussed the homogeneous equation. Now we come to non-homogeneous equations of first degree in x and y. There are two types of it, that is type 4 and type 3 and type 4. So let us see this type 3, that is any equation reducible to homogeneous form. How to reduce a differential equation to homogeneous form. So let us see the theory part. Certain non-homogeneous equation may be made homogeneous by slight modification. The simplest case is the equation that is of the form, any equation of the form, divide the x equal to ax plus by plus c divided by a prime x plus b prime y plus c prime, provided a by a prime is different from b by b prime, and we name this as equation 1. Changing the origin to the point of intersection hk of the line ax plus by plus c equals 0 to this line, to the line a prime x plus b prime y plus c prime equals 0, that is by substituting x is equal to x prime h plus y is equal to y prime k, where hk are constant to be chosen so as to make the equation homogeneous. So if you have this differential equation of this form, first of all this is non-homogeneous. So how to reduce it to homogeneous form? You replace x by x prime plus h and y by y prime plus k, where h and k are constants to be chosen such that this equation become homogeneous. So to make the equation homogeneous, we have dx is equal, if you differentiate this with respect to x, you have dx is equal to dx prime, dy is equal to dy prime, and equation 1 now changes to wherever x is there, you replace it by x prime plus h, y by y prime plus k, similarly in the denominator also. So therefore the equation reduces to dy prime dx prime equal to ax prime plus by prime plus ah plus bk plus c divided by a prime x prime plus b prime y prime plus a prime h plus b prime k plus c prime. We name it as equation 2. Now to determine these constants h and k, we have to choose, so to determine h and k, so we have to make this part, that is ah plus bk plus c equal to 0, and a prime h plus b prime k plus c prime is equal to 0. And from these two equations, find out what are the values of h and k by solving these two, either by subtracting or you have to multiply, so that one part that k cancel to obtain the value of h, and once you get the value of h, substitute it in one of this, you will obtain the value of k. So therefore this equation 2 now will reduce us to the form dy prime dx prime is equal to ax prime plus by prime, because we have choose this equal to 0. And once it is homogeneous, you have to substitute y by vx prime, and from there you will get the solution. So let us see the following problems, how to solve it, how to reduce this differential equation dy dx equal to y minus x plus 1 divided by y plus x minus 5 to homogeneous form. So first of all, let us put x is equal to x prime plus h and y is equal to y prime plus h, so that you have here, so that dx is equal to dx prime, dy is equal to dy prime. Now name this as equation 1. So therefore 1 implies dy prime dx prime is equal to y prime plus k, you replace y by y prime plus k and x by minus x prime minus h plus 1 divided by y prime plus k plus x prime plus h minus 5, which can be written as y prime minus x prime plus k minus h plus 1 divided by, rearrange this, y prime plus x prime plus k plus h minus 5. Now we choose this h and k, choose h and k, so that this term k minus h plus 1 becomes 0 and k plus h minus 5 equal to 0. Now you add these two, k, name this as equation 2 and this as equation 3, adding 2 and 3, 2 plus 3. So this we have k minus h plus 1 equal to 0 and k plus h minus 5 equal to 0. H and h can be cancelled. So you have twice k minus 4 equal to 0, which implies that k here is equal to 2. Once you obtain the value of k equal to, substitute it either in 2 or 3. So this implies that h here will become, if you have 2 here, 2 plus 1, that is 3. So you have minus h is equal to minus 3 or h is equal to 3. So thus we obtain the values of the constants 2 and 3. So therefore dy prime dx prime, now this equation, because we have choose this value equal to 0 both in the denominator and numerator, so therefore this equation reduces to y prime minus x prime divided by y prime plus x prime, which is homogeneous. Now since it is homogeneous, we put y prime is equal to vx prime and differentiate this with respect to x. You have x prime, we have dy prime dx prime is equal to v plus x prime into dv dx. Name this as equation 4. Therefore 4 implies, now you replace this by this value, v plus x prime dv dx prime will be equal to, now replace y by vx prime, so vx prime minus x prime by vx prime plus x prime. So as you can see here, x prime from denominator and numerator can be cancelled, so it reduces to v minus 1 by v plus 1. Now bring this v to one side, so this implies that x prime dv dx prime is equal to v minus 1 divided by v plus 1 minus, bring this v to this side, so you have minus v, which is equal to v minus 1 minus v square minus 1 divided by v plus 1, which is equal to minus 1 plus v square divided by v plus 1. So now you can separate the variables x prime and v prime separately. So this implies that cross multiply to this side, you have v plus 1 divided by 1, or you can write here this 1 plus v plus 1 is same as 1 plus v, cross multiply to this side, this whole thing, and this x prime to this side, divided by 1 plus v square, this minus let it remain, this dx prime you cross multiply, you have here dx prime dv dx prime into x prime, cross multiply to this side, you have minus dx prime by x prime, or you can write here, or you have this into dv, this is equal to this, or you can write dv into 1, you get dv divided by 1 plus v square, and then another one v dv divided by 1 plus v square is equal to minus dx prime by x prime. And from here, or you can write here this dv by 1 plus v square plus d of this can be written as half d of 1 plus v square divided by 1 plus v square. Right hand side will remain as it is, dx prime minus dx prime by x prime. Here it says d of 1 plus v square. This is nothing but differentiation of constant gives you 0, differentiation of v gives you twice v dv. But here you have here only v dv, that's why I'm putting 1 by 2, so that this 2 with this 1 by 2 will get cancelled. So this implies that half of d of 1 plus v square is equal to 1 by 2 twice v dv, which is equal to, and 2 cancel, which is nothing but v dv. So instead of v dv, I'm replacing it by d of 1, half of d of 1 plus v square. So or here you have, so now you can integrate this. Integrating, we get integral of dv by 1 plus v square plus half integral d of 1 plus v square by 1 plus v square is equal to minus integral dx prime by x prime. Now integral of this is nothing but tan inverse of v plus half d of x by x is log x. So instead of x you have 1 plus v square. So you have log of 1 plus v square here is equal to minus log x plus c, where c is an arbitrary constant. Now what is v? The original equation v here, what is v? Y prime is equal to v x prime. So this implies that v here is equal to y prime by x prime. So I'll replace this. So we have here tan inverse, or instead of v I'll replace it by y prime upon x prime. So y prime upon x prime plus half log of 1 plus y prime by x prime the whole square is equal to, this is log prime minus log x prime plus c. Or you can write this as, bring this to this side, you have tan inverse of y prime by x prime plus half log of this 1 plus y prime square by x prime square plus log x prime is equal to c. Bring this minus log x to the left hand side, and we know that this is tan inverse of y prime by x prime plus half log of 1 plus y prime square by x prime square plus half log of x square. Why? Because half log of x square is nothing but log of x square to the power 1 by 2, which is equal to log x. This is x prime. Okay, so x prime square, that is of form m log a is equal to log a to the power m, using these properties of logarithm. So this, or you can write here tan is equal to c, tan inverse of y prime by x prime plus half you can take common. So this gives you log of x prime square plus y prime square divided by x prime square. Log a plus log b is, log a plus log b gives you log ab. So this is x prime square is equal to c. Or you can write here tan inverse of y prime by x prime plus half x prime square cancel. So log of x prime square plus y prime square is equal to c. But x prime and y prime again convert it to x prime, to x and y, the original solution, the original equation. Or you have tan inverse, what we have is x is equal to x prime plus h, y is equal to y prime plus k. So this implies that x prime is equal to x minus h and y prime is equal to y minus k. But what is h? H is 3. So this implies that x prime here will be equal to x minus 3 and y prime is equal to y minus 2. So you have, instead of y prime, replace it by y minus 2 divided by x minus 3 plus half log of this one. X prime is x minus 3 the whole square plus y minus 2 the whole square is equal to c. So which is the required solution? I hope it is clear to you.